Okay, so this was all about the theory part of refraction through prisms. Now we move on to some questions in this topic. The first question is as follows. Okay, so before we move on to the first question, there's something which I have left, I guess. So let's discuss that. Do you know what total internal reflection is? Total internal reflection is when light moves from denser to rarer medium. This is the angle of incidence, this is the angle of reflection, right? Now if you keep increasing the angle of incidence, at some point what happens? The angle of incidence is such that the light, the refracted light, just moves parallel in this direction. Now if you increase the angle of incidence further, there is no refraction, the light rays just reflected back into the medium. The angle I at which, or the critical angle at which this happens, that the angle of the refracted ray moves parallel to the surface of the medium, is known as the critical angle. And after that, when theta is, or angle I is more than the critical angle, the ray is just reflected back. So you know this phenomena. Now let's discuss the concept of total internal reflection in case of prisms. Now in case of prisms, what happens? You see that this was my angle R1, this was my angle R2, this is angle I, and this is the emergent angle E. Now, in case of prisms, at which point total internal reflection can occur? Here you see that light ray is moving from the rarer medium to the denser medium. So here there is no chance of total internal reflection. In this case, the light ray is moving from denser to rarer medium. So in this case, if angle R2 keeps on increasing, at some point what will happen is that the ray will be just reflected back from the surface and total internal reflection will occur at this surface. So let's discuss when this will happen. You know that you know that the angle of prism A is equal to R1 plus R2. Okay, and you also know that mu is equal to sine I by sine R. Now if I ask you, I want to somehow get total internal reflection in this prism, what should I do? What should I do with I such that total internal reflection occurs? The answer is as follows. See, mu is a constant. If I decrease I, this angle is R1, that means what? Angle R1 will also decrease to keep mu constant. Now if angle R1 decreases and A is a constant, so R2 should increase to compensate the decrease in R1. So that means if I decrease I, my R1 decreases and my R2 increases, and since R2 increases, the chances of total internal reflection becomes more prominent. So if I give you a assumption reasoning question or a true-false question which says that the condition for total internal reflection is that I should increase the angle of incidence, is this true or false? My question, again I repeat, is that the condition for total internal reflection is that I should keep on increasing the angle of incidence. The answer to this is false. This is not always true. You might be thinking that in case of when I had only a surface like this was the denser medium, this was the rarer medium, you saw that I was increasing the angle of incidence such that at one point of time this was the refracted ray. When I further increase the angle of incidence, the ray was just reflected back from the surface. So in this case, yeah, it's true that angle of incidence I need to keep increasing to get the phenomena of total internal reflection. But let's say I take the case of prism. In this case, what was happening? In this case, I saw that A was equal to R1 plus R2, and I had to decrease I to decrease R1, which increased R2, and finally TIR was I got the phenomena of total internal reflection. So in this case, I had actually decreased angle of incidence to get the phenomena of total internal reflection. Okay. Now we'll move on to the problems. So the first question is as follows. There's a prism whose angle of prism is given as 90 degrees. Now it is asked that for an angle of incidence of 90 degree and a deviation of beta, what is the refractive index of the prism and what is the sign of delta minimum? So let me repeat the question, that I have a prism whose angle of prism is given as 90 degrees. When the angle of incidence is 90 degrees, the deviation is beta. So I am asked to find the refractive index of the prism and the sign of the minimum angle of deviation. So this is my question. Now before I solve this question, or we proceed with the solution of this question, let me tell you what are the basic things you need to know when you solve any question related to prism. The first thing is that you should be very much conscious regarding geometry. That means you should be very much aware that if this angle is A, then this angle is 90 minus A. If this angle is A, this angle is B, then this what should be the third angle, given the sum of the three angles is 180 degree. So you should be very clear with the geometry. Second thing is that you should know the relation between R1, R2 and A, which is A is equal to R1 plus R2. Also you should know what is delta. Delta is I plus E minus A, where I is the angle of incidence, E is the angle of emergence. Right? Okay. Third thing is that you should be very much aware with the Snell's law, because there are two refracting surfaces, this and this one and this one, and I will be applying Snell's law at this surface and Snell's law at this surface. So you should be very much aware with the Snell's law, which states that mu sine of some angle R is equal to constant. The fourth thing which you should know is that delta minimum is equal to sine of, or not delta minimum, mu is equal to mu when the angle of deviation is minimum, or mu in terms of delta minimum is mu is equal to sine A plus delta minimum by 2 divided by sine of A by 2. Okay. So these are some of the few things which you should keep in mind while solving questions related to prisms. Okay. So now I know these four things, so I'll proceed with the solution. If you don't know these things, I hope that you might not have watched my lectures properly, so I'll suggest you to go back and just have a look on those lectures, and then you should proceed with this question. So in this question, it's given that angle of incidence is 90 and angle of prism is 90 degrees. Both is 90. So I need to find mu.